Hi, this is Philip Cassidy. I'm here with Lab 1 charge tapes for Physics 2. Just a quick introduction to this lab. This lab had three parts, the physical experiment, and then two coding parts that modeled the behavior we saw. So the main experiment was moving tape A towards tape B to determine the electric charge on tape B. We'll get into the details of how that happened shortly. But the purpose of this experiment was to determine the excess charge on a piece of tape. And the important physical principles that we used were the ideas of electric fields and electric forces, how they interact with each other. To go a little more in depth, the excess negative charge on tape A repels the charge on B. And this is modeled with the coding part that we did, a little preview with the blue ball we see here. That's tape B. And that also has the gravitational force exerted by ball B. And just to clarify with the system we have here, the system we're interested in is ball B and what's going on with ball B. The red ball here would be considered part of the surroundings, just to clarify that. But to go more into the results, just a quick overview of the results. This is a picture of the model in the coding part 2. I'll go more into it soon. But the actual experiment we did, we first started with charging the two pieces of tape, which we did by ripping one piece of tape off another. And in this process, there's an electron transfer between the two pieces of tape. And we do this with two different pieces of tape at two different times. And then you get two charged pieces of tape, which want to repel each other. So in our experiment, we have tape B positioned on two blocks. And originally, the initial condition is that the only force acting on B is the force of gravity. So, and that acts downward. And then what you have to do as you start the experiment is move tape A closer and closer to B. And eventually, as you see in the picture, it'll lift up. And at that exact distance where B lifts up is what you're interested in, because at that point, the force of gravity is equal to the electrical force. So what we as we go into this, we knew that the length of the tape was equal to 0.2 meters, and the mass is 0.0002 kilograms, based on the fact that it was, or at least an estimation of 1 gram per 1 meter on the tape. And I got a distance to be 0.01 meters, which I believe is too small, but I'll get into that in a little bit. Gravitational force is mass times the acceleration of gravity is 0.00196 newtons. And that's equivalent to the electrical force at that distance. And the measured electrical charge then is negative 4.67 times 10 to the negative 9th. And then those are the numbers for excess electrons and number of atoms. And the ratio you get is 1.46 times 10 to the negative 7th, which I believe is a justifiable number because you would expect just a couple electrons for the entire amount of atoms to be moving on the tape. So now to just get a little bit more specific with the coding, you already saw this picture, but the electrical charge here was negative 2.33 times 10 to the negative 9th. And in this model, we used just single particles to represent the behavior of the tape, which isn't completely accurate. And I'll kind of show you as we move on to coding part 2. The electric charge here is negative 1.75 times 10 to the negative 9th. And since we see that this number is lower than the original number here that we got for the measured electric charge, I believe that the distance was too small from what I measured, because this means that there's less actual charge required at that distance than what was expected. And as you see here in model 2, this represents all those green arrows are all the electric fields that act on the piece of tape. So the red is tape B and the blue is tape A. And so some sources of error, there could be other forces acting on the tape. I don't think this is as big a problem as the human error, for just me eyeballing it with the ruler is very problematic. And I'm sure I made some big errors there, and that could be magnitudes of difference in my answer. And now some of the what if questions. If the charges were reversed, I believe the electrical charges would be positive, but we wouldn't see much of a change in the effects of the lab. They would still have a similar behavior, like the charges would still repel each other, the two tapes. And as I kind of mentioned, part two is more of the coding is more accurate than part one because it takes into account that the fact that the tape is a line charge rather than just a single point. And thank you for listening.